Okay, this is a continuation of the practice test for MAC1140 Pre-Calculus. We're talking about the topics on exam 3, which is chapter 11, and we have moved on to numbers 12 through 28 will be covered in this video. Okay, so beginning with problem number 12. This is the system that you've been given. In this problem, let's see, the instructions are, let me just get back to that problem real quick. Okay, the instructions for that problem are just to solve the system. If the system has no solutions, say that it is inconsistent. So you are doing these by hand. Okay, so in this particular problem, we're going to just try and decide. I put some notes for you right here because a lot of students seem to be get all flustered by a 3-variable system, and they the main problem from what I gather is that they don't know how to start. So what you're supposed to decide by analyzing the 3 equations is which variable would it be easiest to get rid of. And you're supposed to stick to that plan twice in a row. And that is the comments that I've left for you here. Decide which of the 3 variables to get rid of and proceed to eliminate that same variable twice in a row using 2 different equations each time you get rid of that same variable. So let's take a look at what we have here. Let me get a little bit more organized here. Okay. Making some room. Okay, so let's see. I think what would probably be the easiest thing is to get rid of the x's. Although you can go after whatever variable you want, I'm going to make a choice to get rid of the x's. I'm going to be using equations 1 and 2. With regard to why I'm making that decision, I see that the coefficient here is 1, the coefficient here is -1. Those are really easy things that can be manipulated to get rid of that particular variable in the other equations. As long as you have that variable with a coefficient of 1, it can very easily be used to cancel out other coefficients. So I'm drawn to variables that have a coefficient of either 1 or -1. Hold on for 1 second. Okay, so I am going to be using equations 1 and 2, and I'm going to be eliminating x. Okay, now when you decide, what you're going to get rid of, take out the 2 equations that you're going to work on. You can only be using 2 equations at a time when you get this process started, solving a 3-variable system. You begin by working with 2 equations at a time, which is just what it says right here in my notes for you regarding how to get started. So I'm going to use -x plus y plus 2z equal to 0. Just take it out of the system, and then equation 2 is +x plus 2y plus z. And do you see how the x variable is already ready to go? Because if you're going to be using elimination, you're just looking for the variable that you're trying to get rid of for it to have opposite sign coefficients, and that's already occurring. So you can jump right into the combination of these 2 equations. So this plus this cancels, this plus this is 3y, this plus this is 3z, and that's equal to 6. Hold that equation. What you're trying to do by doing this is you're trying to create 2 equations that only have 2 variables. And then you'll work on that little mini system to find the values of the 2 variables. And then you'll go back to the main system with your 2 values and plug it into any of these 3 equations. That's the general game plan. Stick to this plan. Once again, you want to try and eliminate the same variable, but you want to use different equations than what you use right here. Now you can use one of these, but at least one of the equations has to be different in the 2 equations that that you're going to use right now. Okay, so we're going to stick to the same plan. And that is to eliminate the x's. Stick with that. Okay, this time what I'm going to do is I'm going to use equations, let's see, 2 and 3. I'll use 2 and 3. And I'm calling this equation 1, equation 2, equation 3. I'm always numbering them, just going down. So I'm not going to sit there and number them for every single problem, but just so you know what I'm calling equations 1, 2, and 3. So once again, remove the equations that you are focusing on. I am going to focus on equation 2 and 3 at the moment. You don't want to do your work here. You want to remove it. Okay, so equation 2 is x plus 2y plus z is equal to 6. Okay, then equation 3 is negative 2x minus y plus z equal to negative 6. Make your work very clear on this test because I have to be able to follow everything you do. Okay, so if I want to get rid of the x's, sticking to the same plan, that that I had for right here, then that means I would be multiplying this top equation by 2. Because if I have a negative 2 down below, that means that I want to have a positive 2 in the top equation. That's what I'm going to do. I'm going to multiply by 2 right here. I'm going to put my work down here. So that top equation is going to be 2x plus 4y plus 2z equal to 12. Equation below it, I will not be changing at all because I don't need to. I already have opposite signed coefficients in my x variable. And combine. These will cancel. 4 take away 1 is 3y. 2 plus 1 is 3z. And 12 minus 6 is 6. Okay, look at the two equations you have. If they are identical, that means that the solutions, and you could go further with this, if you don't happen to notice or remember that if you have two identical equations, you're going to get infinite solutions. And if you get infinite solutions at this juncture in the problem where you only have two variables, that means the entire system has infinite solutions. So let's say you didn't notice that that's what was going on, and you then went to the next step that you would typically go to in a 3-variable system. You would get these two mini equations that now have one less variable than what you started with. You would line them up as though that was your actual system, even though it's really just a mini representation of the main system. And you would go about the business of getting rid of yet another variable. And that could either be the y's or the x's. So let's say that you were going to try and eliminate the y's. Let's say that you didn't realize by looking at these that you would get infinite solutions. So now I'm going to eliminate the y's. That's my next plan. So once you stick to the same plan twice in a row, you choose a variable to eliminate, and you do that twice in a row, and you get these two little mini equations. Then you can change then you're going to have to change what variable you'll be eliminating because you won't have that variable anymore. So you can't stick to that plan a third time. So here we go. I'm going to multiply this by -1, causing a -3 to happen here so that it will cancel with the +3 below. I'm going to carry these out here. You can either work going down. I mean, I prefer to go off to the side. Just -3y, -3z, and -6. Right here is where it should smack you right in the face that you have infinite solutions. Anytime you're solving a system, and in the process of doing so, all the variables disappear. They all cancel away. and you get a true statement. Any number is equal to itself. That is true. That's a true statement. That implies that you have infinite solutions. If you have infinite solutions, you're going to have to know how to represent the answer, how to talk about the equations with respect to infinite solutions. You can't just stop right here. Okay? I repeat, you cannot stop here. You need to get the equations in a way that implies infinite solutions. So let's talk about that. As you're doing this problem, I want you to go back up to these. Let's see, where can we go with this? Let's go to these equations that we have in our mini systems. The 3y plus 3z equal to 6, and either one of these is the same thing. Okay, so here we go. We're going to express your solutions using the equations in the system. That includes the ability to use the mini equations that you've created. So you're going to start off like this. Last variable in the system, which is z, they go in alphabetical order, you're going to say that variable can be any real number. It can be any real number as long as the following conditions are applied to any real number being used for z. And that is this. Now once you state this will be the first thing that you state. Second thing you're going to do is you're going to express the other equations in the system. And like I said, those mini equations that you came up with are part of the system. Express the other equations in the system in terms of the variable that you just said could be any real number. So in terms of z. You're going to express the other equations in terms of z. For instance, take one of these mini equations. They were both the same. I'm going to write it right here to show you how you express them in terms of z. Okay, so first, right now what I'm doing is I'm going to get an equation for y in terms of z. So I'm going to leave the y there, bring the 3z to the other side. The 6 was already there, so I moved this to the other side. It becomes negative. Make that a little bit clearer. So it's negative 3z. Once you bring this over here, the 6 was positive. Divide off the 3, and you get y is equal to negative 3z divided by 3 is negative z. 6 divided by 3 is 2. Okay, and you can write this as negative z plus 2, or you can write it as 2 minus z. Either way, that they both mean the same exact thing. So this is what we call an expression for y in terms of z. In other words, you will isolate the all of the two remaining variables, because you've already talked about z. So that means you have to come up with an expression for y and an expression for x, and it should have nothing but z's on the right-hand side. That's called giving an expression in terms of a particular variable, and that variable will be the one that you spoke about when you said it could be any real number. Okay, so that is 3. What we just did here is we expressed y in terms of z. That's what we just did there. Now we're going to express x in terms of z. This is only required when you have infinite solutions. Okay, so now what I need to do is go back to the main system because those are the ones that had x in it. And what you're going to do is you're going to back substitute some of these other expressions that you've created. Now, if I'm going to give an expression for x in terms of z, I think I like this one, equation 2, because the x already has a positive in front of it rather than having to deal with getting rid of that negative and potentially making mistakes there. So I choose to use equation 2, which is x plus, let me just remove it from the system so we can focus on what we're doing here. Okay, move this up so you can see it. Okay, so if I'm going to give an expression for x in terms of z, I have to isolate x, and I cannot have any variable other than z. That's what it means to give an answer in terms of z on the right side of the equation, yet I have a y. So I need to get rid of that. Well, we can back substitute right here. See how you have this expression for y? You can put that right in there, and then you won't have a y anymore. You'll have all of this, and then you'll be able to continue with your mission to express x in terms of z. So x plus 2y, I am back substituting an expression that I just got, negative z plus 2. I put that in for my y variable, plus z is equal to negative 6. Okay, now I have nothing but x's and z's, and so I can isolate for x. First, I'm going to get rid of the parentheses. Positive 2 times negative z is negative 2z. 2 times 2 is 4, plus that z that's right there. I'm going to continue to isolate for x. First, I'm going to combine my z's. I'm going to go negative 2z plus z is negative z plus the 4 that's here. Now getting everything on the opposite side except the x. So this z will come over here and be a positive z. The positive 4 will come over here and be a negative 4. So in the end, x is equal to, these are gone, z minus, let me see what I got for this. Hold on one second, I want to check my math here. Let's see, for this I got 2 minus z, and I want to make sure what I have here. Let me go over this real quick. So it was x plus 2y plus z is equal to, I think I copied a negative here accidentally, so let me get rid of that. I knew there was something different. It was supposed to be positive 6. See, if you look right up here in this main equation, it was supposed to be x plus 2y plus z is equal to 6. That's the equation that I'm using, and I accidentally copied negative 6. So let me get rid of that before I give my final answer, because it only affects the final answer, that negative. I haven't used it yet because what's over here on the right side is not used until the last moment. So it will be positive 6 minus 4 once I bring this 4 over here, and the negative z will turn into a positive z. So this will be positive z plus 2. And that's your expression for x. Okay, so now what you're going to do is you're going to look for an answer that says z can be any real number. That will be part of the answer. This is always how you give an answer for infinite solutions. Then you have an expression for y in terms of z, and you have an expression for x in terms of z. So on this practice test, that was choice C. X is equal to z plus 2. That's what we got. And y is equal to 2 with a negative z. 2 minus z and that's what we get, 2 minus z. And then they also said z is any real number. Okay, choice C. Yep, those are not so fun because none of the 3 variable systems are, you know, especially when you're going to solve it by hand. But you are required in this class to demonstrate that you have moved on with your algebraic skills and that you're now doing things that are at a higher level than what you came out of college algebra with. So that means being able to do a 3 variable system, not just by your calculator, because when you do it by your calculator is doing the entire job for you. So what I can say to summarize this 3 variable system deal, show that you can do it once or twice on the test, and then you can move to some calculator problems. Then you can do some of them by calculator. So as long as you demonstrate it, let's say at least once. Okay, the test is going to be very specific about what you have to show work for this test. Okay, so that's number 12. All right, moving on to number 13. Okay, number 13, the instructions change to write the augmented matrix for the system, and there's really no work for that. You're just going to clip off these coefficients and dump them into a matrix like that. So here's the system right here, augmented matrix. This means you take the coefficients off the variable. This would be for your x, this would be for your y, and then the constant is over here. You have a line that comes before your constant, and then this one would be 2, 5, 36. That's it. So there's literally no work. Okay, that would be the number 13, D. 4, negative 2, 0, 2, 5, 36. Same thing for 14, only this one's a 3 variable system, so again, no work, just take off those coefficients. So 4. Be careful with missing variables, like for instance, see how there's no y in here? So it's 0 for the y column, because every column represents a variable. Like this was the x variable, this was the y variable. Now you're going to have an x column, a y column, a z column, and then your constants. Okay, so it was 4 for x, 0 for y, negative 2 for z. Then here it's, whoops, put that in the wrong place. There is no x here, so it's 0 for x, negative 2 for y, and 3 for z. The constants have been 12 in the first row, 26 in the second row, and then there's one more row. So that one is 2, 5, 9, it's not missing anything, and 81. Okay, and that particular answer for 14 was C. 4, 0, negative 2, 12, 0, negative 2, 3, 26, and 2, 5, 9, 81. Okay, moving to 15. In problem number 15, let's see what the directions went to. Okay, I think we're going back the other way this time. This one says write the system of equations associated with the augmented matrix. Do not solve, so you're just going back the other way. In other words, reattaching the x's and the y's. There's also no work for this. You just jump into the answer. There's no mechanics to be done. So this would represent 2x plus 5y, this being the x column, this being the y column, this being the constants on the other side of the equal sign. Then the next equation would be 2x plus 2y equal to 28. And number 15, that was choice C. Okay, moving to 16. In problem number 16, we have a 3 variable system in x, y, and z. Again, these are the constants over on the other side of the equal sign. Okay, so the system represented by this augmented matrix is negative 9x plus 3y plus 6z equal to negative 2. Next equation is negative 5x minus 3y equal to negative 9. Next equation, negative 2x minus 9z equal to 3. And that answer for number 16, 6z, negative 5x, negative 3y, and negative 9, so all negatives in the second row, and that would be choice A. Okay, moving to 17. Problem number 17. Okay, directions change again. Determine whether the system corresponding to the given augmented matrix is consistent or inconsistent. If it's consistent, give the solution. Okay, so I've copied these over here. Okay, so this is the easiest one because there's just no work at all that you would need to say. It's when there's infinite solutions that you need to know how to express each variable in terms of the number that you are saying can be any real number. This implies, this bottom row right here, this implies no solution, because what this really means is this being in the x column, this being in the y column, this being in the z column. That means 0 times x plus 0 times y plus 0 times z is equal to 3, and that is impossible. There's no way that there can be any values at all, ever, that you could plug in here, here, and here, then multiply each one by 0 and end up getting a 3. So because it is impossible, that implies that there is no solution to this system. And the terminology for that is inconsistent. You can stop it right there. And you don't have to write all this. You can just jump right into saying what they asked you for in the instructions. Determine whether it's consistent or inconsistent. And it stops there. That one row tells you that it's inconsistent. It'll be the bottom row. In number 18, we have something different in the bottom row. This implies consistency. This is consistent. It actually means infinite solutions when you get a string of zeros like this on the bottom row. And when it is, I shouldn't have put that there because I'm chewing up the space that I'm going to need to talk about my variables. So this row right here implies that consistent just means that there are answers. There are so many answers in this particular system that we say they are infinite. And here's how you give the answers. So for number 18, last variable in the system would be z. This is x, remember. This is y. This is z. So you're going to start off by stating z can be any real number, and then you're going to look for strings of numbers in this augmented matrix that only have two variables in them so that you can express the other variables in terms of z. Okay, so we've already talked about the variable z, stating that it can be any real number, but only under the following conditions. And I'm about to give those conditions. Express the other variables in terms of z. I have room to write the word of. Okay, so here we go. If I look one equation up, that says that only has two variables, so that's nice, and so does this one. So they made this problem easy for you. Because there are zeros in the row, that means that those are only two variables, which will give you an opportunity to do what I just stated here. So this one says 1y plus 4z is equal to -4. So this gives you a way to express y in terms of z. You can just go like this. You can bring this over here, which will make it -4z, and then you have an expression for y. Y is equal to -4z -4z minus 4. So there's one of the expressions you're going to talk about. And then if you look at, so this was equation 2 that I got this from. And then if you look at, let's see, I'm going to write it down here. If you look at equation 1, that says 1x minus 2z is equal to 6. And if you were to bring this over here, you would have x is equal to 6 plus 2z. So you have an expression for x in terms of z, in other words, nothing but z's over here, and you have an expression for y in terms of z. And those are the things that you're going to find in the answer. You're going to find this, and this, as well as the fact that you are stating that this system is consistent. I don't know if they'll make you say infinite solutions, but that's exactly what this means, these expressions right here. So they may just have you say consistent and give the expressions. Let's see what's available there. So for number 18, yeah, they just mentioned consistent. Consistent just means it has an answer, and these expressions right here are explicit regarding what kind of solutions it has. Okay, so consistent means just has a solution, and then they gave you z is any real number. They gave you the expression for x, which is what we got, 6 plus 2z, and they gave you the expression for y, which is -4 minus 4z. Okay, moving on to 19. Perform row operations on the given augmented matrix. They want you to go row 1, the numbers in row 1, each one of them times 4, and then add them to the entries in the corresponding entries in row 3. This big R, that's where you're going to dump your answer. So here's the problem. Let's get on that one. Okay, I'll put my work over here. Or maybe I'll put it underneath and then I'll show you what the new matrix looks like over here. Okay, so don't forget, maybe highlight this or circle it. Your answer is going to go right here. Your answers are going to go in row 3. Okay, I'm going to do the mechanics here. I'm going to go 4 times anything I find in row 1. So 4 times -7 is -28. And I think you might want to set yourself up in a way that's going to not allow you to put these numbers in the wrong place. You are only to be changing row 3. So leave that one blank, but insert all the numbers from the main augmented matrix right back where they belong. I think you should do that to start with, because it'll help you not to put the answers that we're going to get right now in the wrong row. So -5, -1, and -10. So we're only replacing row 3. Do whatever you need to do to remind yourself of that. And now what I'm going to do underneath the main matrix is I'm going to just show my work. So I'm concentrate on what I'm doing. So 4 times this entry in row 1, 4 times -7 is -28, and then I'm going to be adding it to the corresponding entry right here in row 1. So that's going to be equal to 0. Okay, so that goes there. Now my next bit of work, again, multiply the entries in row 1 by 4. Move over to this one. So 4 times -5, -20. I'm just keeping track of my work here. And then I'm going to add whatever I find in row 3 in that same column, because I'm working on row 1, column 2. So what's in row 3, column 2 is that negative 6. So now I get negative 26, and that'll be my next entry in row 3. Likewise, I'm going to go 4 times row 1, column 3, and that will be negative 4. Okay, and then I'm going to add it to the corresponding entry in row 3, which would be 6. And that turns out to be 2. Okay, last one, I'm going to go 4 times this fourth column over here in row 1, so that'll be negative 40. There's another room here, so I'll put it here. So that'll be negative 40 added to the corresponding entry in row 3. Okay, so this is going to be negative 22. Okay, so we want to look for an answer with 0, negative 26 to negative 22. So number 19, and that would be choice B. 0, negative 26 to negative 22. And then these are the numbers from the main augmented matrix. Okay, moving on to number 20. Okay, problem number 20. Let me flip. Okay. So same set of instructions here. They're giving you a row operation that they want you to complete. Okay, so once again, let's get ourselves set up for success. We're going to be putting our answer right in row 2. Okay, and just so that we don't put our numbers in the wrong place, let me give myself a little bit more room to actually do my work. So I'm just going to put the arrow up here. This will be where I'm going to put my answers. Okay, so I want to remember that I am only changing row 2. Okay, you're doing these operations, dumping the answers in row 2. So maybe I'll just go like this to remind myself once again that this is where the brand new numbers will go, yet all the other numbers are going to remain the same. So it's 1, negative 4, 1. Put those in place so you don't accidentally go putting the numbers that you're going to get right now in row 1. And then this will be 4. Row 3 remains the way it is. And I'll put my new answers. I'm going to do the work right here. Okay, this says multiply the entries in row 1 times negative 3. So negative 3 times 1 is negative 3. And you should add it to the corresponding entry in row 2. Okay, so that was negative 3 plus negative 5. And that would be negative 8. Okay, next is going to be, again, negative 3 times the entries in row 1. I'm on this column now, so that's going to be negative 3 times negative 4 is 12. And then I'm going to add it to the corresponding entry in row 2, which would be 0. And that will be 12. So that goes there. Carry out that same plan. Negative 3 times the entries in row 1, so negative 3 times 1 is negative 3. Add it to the corresponding entry in row 2, which is 5. And then when you add these, you get 2. Moving on to that last calculation, negative 3 times row 1 entries, which would be negative 12, plus corresponding entry in row 2 would be negative 3, and that's going to give you negative 15. Okay, so we have replaced all entries in row 2 after completing these row operations. You will be doing those by hand. Okay, then we get to the next problem where you've been asked to use row operations to solve. So I think for the 2 variable systems, we'll do it all the way by row operations, and then when we like numbers 21 and 22, because you're going to create a matrix and do row operations to try and get zeros in the appropriate place. And then when we get to the 3 variable system, I think it'll be a little easier for you if we do row operations up to a certain point, and then we will create like a 2 variable system and continue with the problem using elimination. Then I'll also let you do a couple of them using row operations in your calculator. But I want you to show your work based on the instructions in the test. If it says to show them by hand, you will do the whole thing by hand. Obviously, you can use your calculator to help you add and subtract, but you just won't be using matrix operations unless it says you can. Okay, so the instructions, like I said, are very explicit on that test. All right, so let's see. Moving on to number 21, let's create an augmented matrix here. So it would be 5 for x, 2 for y, 2 for the constant. Likewise over here, he'd have 4 for x, 6 for y, 28 for the constant. Okay, so now I have my augmented matrix, and I think what I'm going to do here is I'm going to replace row 2 by doing this. I think what I'm going to do is, because if I try to create a 0 here, it would be much harder. This can be turned into this quite easily, whereas that is not the case here, nor is that the case here, because you would have fractions involved. So I'm just going to multiply this by -3, add it to this row, and when I add it to this row, it'll create a 0. I'll therefore only have 1 variable in this bottom row, and the minute that I have that answer, because I'm creating a 0, once I solve for x, I'll then be able to substitute to get y. So that's going to be my plan. I'm going to write it out just like the instructions looked in the previous few problems where we did row operations. So I'm going to create a brand new row 2 by doing this operation. I'm going to multiply the entries in row 1. I'm specifically zoning in on these guys because I'm trying to create some zeros. I'm going to multiply that by -3, and then I'm going to add it to row 2 because that'll create a -6. Added to this will create a 0. All right, so let's go from here to down here. Okay, so if I do this, now remember, this is where you're putting your new numbers. You got to be careful that you're not just dumping them wherever. So these are going to stay the same. And this row right here is going to change when you're doing row operations. Okay, so let's see. I'm going to do -3 times row 1. That would be -15. And then I'm going to add it to the number in row 2, which is going to be a 4. Okay, -3 times 5 is -15, plus the entry in row 2 is 4, and that's going to be -11. Putting these new entries in row 2. Same plan now. Let's go -3 times row 1. That's going to be -6. Added to the entry right below it, and that's going to be 0. Perfect. Okay, then I'm going to do it again for the constant. I'm going to go -3 times row 1. It's going to be -6, this time adding it to 28. And that will be 22. Okay, as soon as you have zeroed out either the x or the y. We've gotten the y to go away because remember, this is x, this is y, this is the constant. You can go in for your answer right now. You could say negative 11x is equal to, because there's no y, 22. And that tells you that divide by negative 11, divide by negative 11, and you find out that x is equal to negative 2. So here's one answer. And then you could go ahead and just go and grab the equation right above that and go and get the answer for, what do we have now? Get the answer for y. So looking at this same equation, I could also write this. 5x plus 2y is equal to 2. Just by looking at this. 5x plus 2y is equal to 2. I now know that x is negative 2, and y I have not yet solved for. So it's negative 10 plus 2y. Move this over here. And then divide by 2, divide by 2, and you have y is equal to 6. Okay, those are your two answers. Okay, so let's check these answers as we're going along. Number 20. Let's see, what have I gotten in number 20? Negative 8, 12, 2, negative 15. And that was choice A. And then for 21, I got x is negative 2 and y is 6. What's for 21? X is negative 2 and y is 6. Okay, now we're on to 22. On the practice test, you have all the answers anyway for the last couple of pages. Okay, so 22, same thing. Okay, so augmented matrix that goes with this is 2, negative 2, negative 1, and then it's 4, negative 4, and 5. Okay, then I think what I'm going to do in this one is multiply row 1 by negative 2 because that will create a positive 4. So when I add it to that, that'll create a 0. Okay, my plan is to put this answer in row 2 by doing this operation, multiplying this entire row 1 by negative 2, thus creating a 4, then adding there, and I'll get a 0. Okay, that's my plan. So, once again, I'm going to do the work down here. I think you should, make like a little indication to yourself that you're going to be putting this in row 2, and that row 1 is going to stay the same. Because if you put those numbers that are going to stay the same in place, you won't accidentally put your new calculations in the wrong row. Okay, so here's the work. When I go negative 2 times row 1, that's negative 4. Added to the entry below that, which is also 4. So negative 2 times 2 is, just like this plan says, is negative 4. Negative 4 plus 4 is 0. Okay, then I'm going to do the same thing again. Negative 2 times this times negative 2 would be positive 4. Positive 4 plus negative 4 is 0 yet again. And then my last calculation will be negative 2 times row 1. This time I'm in column 3. So that'll be positive 2 added to the corresponding entry below it, which is 5, and that will be 7. So what this says, anytime you have a string of variables all with 0 coefficients, and they claim that that's equal to a value, that is impossible, because this means 0 times some value of x plus 0 times some value of y is 7. Impossible. Therefore, the solution is inconsistent, which means there's no solution. Okay, so inconsistent for that one. And that would be choice A. Okay, moving on to 23. Here's 23. Okay, so I'm going to create the augmented matrix right here. So it's 1, negative 1, 5, negative 23, 2 for x, 0 for y, 1 for z. Sorry, I make my ones one way one time and then a different way the next time. They're all ones. Negative 4, and then this is 1, 3, 1. Let's just make them all the same. And then 5. Okay, check those real quick. It goes 1, negative 1, 5, negative 23, 2, 0, 1, negative 4, and then 1, 3, 1, 5. Okay, got them copied right. Now I have to come up with a plan as to where I'm going to create the zeros. This gives me an idea right here. Since the y's in the y column, there's already a 0, I think I would like to stick to that plan. Okay, so here's the reasoning. Since there's a 0 in the y column, you might want to try and get another 0 in the y column. Like, in other words, get another 0 down here, because then you'd have an equation. You'd have 2 equations that are missing the y, so you'd have 2 equations with only 2 variables, and you would be able to create this mini system in only 2 variables, because right now you have 3 variables. So I think what I'm going to do is try to create a 0 right here by multiplying this value by 3 and then adding it to that. If I'm at whatever the row that you're adding it to is the one that gets all new values. So this row 3 down here is where my answer is going to go, and this is the plan. I am multiplying the entries in row 1. I was concentrating on this because I knew I could turn it into a negative 3 just by multiplying by 3. So row 1 entries are going to be multiplied by 3 and then added to the entries in row 3. Okay, here's what my resulting matrix would look like. First of all, if you know that you're going to be replacing row 3, leave that one blank and put all the other ones back where they belong. Okay, so we're going to have a 1, then we're going to have a negative 1, then we're going to have a 5, then we're going to have a negative 23. Okay. Then in the second row, it's 2, 0, 1, and negative 4. Okay, this is the plan for getting each of these values. they are going in row 3. All right, so let's see. 3 times row 1 would be 3. Corresponding entry, if I'm adding it to row 3, would be to add it to this 1 right here, and that would give me 4. Next calculation. 3 times row 1 would give me -3. Add it to the corresponding entry in row 3, and that would give me another 0 in the y column. These are the x's, these are the y's, these are the z's. It's just like when we were solving these 3 variable systems by hand, and I told you to stick to the same plan twice. So that's kind of what I went with right here. That is exactly what I went with. Okay, continuing with this procedure. 3 times row 1 entry, that would be 15, plus the corresponding entry in row 3 would be 16. One more time. 3 times what's in row 1 would be -69, because you're multiplying this times 3 and this times 3. And then add it to the corresponding entry in row 3, and that would be -64. All right. Hold on for 1 second. I'll find my mouse, except I can't find it. All right. So now what happens is you have 2 mini reduced or a mini system. This one is missing a variable because there's a 0 there, and this one. So I think when you come to these 3 variable systems, instead of doing row operations the entire way to the end of the problem, get it down to 2 variables in 2 of the equations, which is what's going on right here. You have only 2 variables in equation 2 and 3. So I'm going to remove that 2 variable mini system there, which is 2x plus z equal to -4. 2x plus z is equal to -4. And then the equation below it is 4x plus 16z is equal to -64. And I'm going to continue this through the process of elimination. Okay, specifically, I'm going to get rid of the x's. I'm going to multiply this by -2, thus creating a -4, so that when I add it to the positive 4x, the x's will be gone, and I'll be able to solve for z. So here's my answers. -2 times 2x would be -4x. -2 times z would be -2z. And then -2 times -4 is 8. Bring the other equation over as is. 4x 16z and -64. Okay, so that cancels, and this plus this is 14z. And this plus this would be -56. Divide by 14, divide by 14, and you get z is equal to -4. Okay, so we have z. Now that we know what z is, go ahead and stick with the 2 variable system that you removed from this augmented matrix. You could use either this one or this one and go plug in z. Okay, so substitute z equal to -4. So I'm going to use this one. Before I multiplied it by -2, it was 2x plus z equal to -4. I know that the z is -4, so I'm going to put that right in here. I'll move this to the other side, at which point it's going to become +4. And then this combined with this will be 0, and then divide by 2, divide by 2, and now you have another solution or another value. Okay, one more. We're going to go all the way back to a 3-variable equation. All the way back to the main system to grab one of those. So you can use any one that you want. You can use equation 1, equation 2, equation 3, whatever you like. I think I'm going to use equation 3. That's just my choice. Use whatever you want. I'm using it because I'm solving for, let's see, actually, is that the best one? Well, you know you can't use equation 2 because you're trying to solve for, the only thing that you don't know is y. That's the one that you're looking for. So obviously you need an equation with y in it, so you can't use equation 2. You can use this one with the negative in front of it, or you can use the bottom one. I don't know that either one of them are any simpler, so I'm just going to use equation 3. So I'm going to go x, just write the equation first before you start plugging into it. You can jump into plugging into it if you want. I just think it helps you focus. Okay, so then we know x is 0. We don't know what 3y is, and then z is -4. Okay, so we have 3y, because 0 plus 3y is just 3y, and we're going to move this over here, at which point it becomes +4. So that's not there anymore. It's over here on the other side, presenting as a +4, which gives us 9. Then divide by 3, divide by 3, and there you have all 3 answers. You'll also be showing that you can solve one of these by hand, and then you can do the other ones by calculator if you'd like. Okay, so that is 23, I think that was. And why don't we check the answer too? Here we got 0 for x, 3 for y, and we got -4 for z. Okay, so that was 23, which is d 0, 3, and z is -4. Okay, moving to 24. This is exhausting. Okay, so 24. Make sure I got this right. 3, -2, 1, -7, 1, 1, -2, 12, and 3, 1, 3, 1, -1, 10. Okay, so the numbers are right. I'm going to create my augmented matrix. Three, -2, 1, -7, then in 1, 1, -2, 1, 1, -2, and then a 12 over here, and then 3, 1, -1, and then 10. Okay, so there's my augmented matrix. And I think what a good plan for this one would be, I'm trying to figure out, where it would be easiest to create zeros. And it has to be in the same column twice, just as though you were solving it when it's in this form. You try to pick a variable to eliminate twice in a row. I am going to go after the x's, and I am specifically going to try and zero out this row right here by using the 1 to do so. In other words, if I multiply row 2 by -3, that would create a -3 here, so that when I add it to this, that would zero it out in the x's, and I wouldn't have an x there. I can do the same thing in the equation below it. I can multiply row 2 by -3, add it to this row, and I'll have a 0 there too. Therefore, I will have gotten rid of the x's in 2 of my equations, only have a y and a z, thus having a 2-variable system. So that's my plan. For number 24, I'm going to get the 0 in row 1 first. So my new row 1 is going to be this row 2 multiplied by -3, and then I'm going to add that to row 1. Okay, so everything is going to go, these new numbers are going to go in row 1. Here they are, right here. I'm going to remind myself that I am putting the new values in row 1 by leaving those blank and putting the other numbers right back where they are. 1, 1, -2, 12, and the row below that, which is 3, 1, -1, 10. Okay, I'm going to carry this out. So -3 times row 2, -3 times row 2, so that would be -3 added to the entry in row 1 above it. Added to 3 would be equal to 0. Okay, next time I carry out the plan. -3 times row 2, which would be -3 again, added to the entry in row 1, and that would give me -5. Okay, carry out the same plan. -3 times row 2 would be 6. 6 added to the entry in row 1 right above it would be 7. Okay, one more time. -3 times row 2 entry, which is -36, added to the entry right above it, which is -7, and that would be equal to -43. Okay. All right, so then once I get this, now that I have a 0 here, that means that the x is gone in this particular equation. The y and the z remain. So I need another equation where the x is gone, and like I said, I'm going to use anything that has 1s in it is a strong way to get rid of anything else that you don't want around. So because you can turn that 1 into any number without hardly any work. So my next plan, this was my first bit of row operations and all the new numbers went there. Now I'm going to multiply row 2 by -3 again, add it to row 3. And again, where you're adding it is where the new numbers go. So my new row 3 is going to be row 2 times -3. Then adding it to the entries in row 3. That's how I'm going to create this next matrix. Okay, here's my work. So it's going to be -3 times row 2 is -3 added to the entry in row 3. And again, you might want to set up yourself to put the new numbers in row 3. Leave these blank so you can put the new numbers and reinsert the numbers that you just had. 0, -5, 7, -43, and 1, 1, -2, 12. Because if you put those in there, then you won't put these values that we're working on right now in either of those rows. So back to the plan. It's row 2 entries times -3 added to the entries in row 3 on the previous augmented matrix in the step above. So this times this is -3 plus the 3 equal to 0. Okay, then it's -3 times the next entry in row 2, -3 added to 1. And that's -2. Then it's -3 times the next entry in row 2, and that would be 6 added to -1. And that would be 5. So -2, this one would be 5. One more entry. -3 times 12 would be -36 added to the entry in row 1. Oops, I'm reading that one. I'm supposed to be reading this command right now. Let me make sure that I did these correct. This was -3 added to this. This was -3 added to 1. This was -3 added to -1. Correct. Then it's -3 times this is -36 added to 10. Okay. So now I have two equations that are missing the x. And so now I can take out my mini system that contains only x and y, and that's what I'm going to remove. So remove two variable system. And that would be -5y, that's the y column, because this is the x column, this is y, this is z. I don't have any room to write that up there. So -5y plus 7z is equal to -43. And then the one down here in equation 3, that would be -2y plus 5z is equal to -26. Okay, so now what I want to do is I want to look at this and decide what new variable I'm going to get rid of. By creating these zeros here, I got rid of the x's in equation 1 and equation 2. Now I only have y and z as my variables, and I can either get rid of the y's or get rid of the z's. Either one is just as easy, or you're just going to have slightly bigger numbers if you go after the z. Because the smallest number that this and this go into is 35, so you'd have to change both of them into a 35, make one of them negative, one of them positive, whereas here you can go for tens. I'm going to go after the tens. Okay, so that means I'm going to be multiplying this by 2. That'll be my -10. And I'm going to want this to be a positive 10, so that means I'm going to have to multiply it by -5. So coming down here, all the way down here, after doing the multiplication, I would have -10y, and 2 times 7 is 14z, and then 2 times -43 is -86. Below, I'm multiplying by -5, so -5 times -2 is 10y. -5 times +5 is -25z. And then -5 times 26 would be 130, I believe. Is, yep, 130. Okay, and now the y's are gone. Okay, so I can cancel those, add these together. When you combine this with this, you're going to get -11z. And when you add these together, I believe you're going to get 44, but let's check that out. 130 combined with -86, yes. 44, divide by -11, divide by -11, and we get, I'll just keep going down here, we have z is equal to -4. So that's one of the answers. Okay, then you could take either of the equations that you had in the step above. You can use these, but that'll just make the numbers bigger. So you can use one of these equations and plug the z value in. So that's what I'm going to do. So I'm using a two-variable equation again, trying to solve for y. I'm going to use the bottom one. I'm going to write it first just so I can focus on it. Okay, then I'm going to go plug in the z value that I already know, which is -4. Okay, then I'm going to leave the 2y there, and I'm going to take this -20 to the opposite side, at which point it will be +20. So this will be -26 combined with 20, -6. And then I'm going to divide this by -2, this by -2, and I'm going to get y is equal to -3. Whoops. This was supposed to be a -2, so this would be +3. Divide by -2, divide by -2. I didn't write the negative, so that is +3. Got two answers. And now go grab a 3-variable equation to finish off and find that last value. I need something with an x in it. So if I come to the main system here that I started with, I think I'm going to use equation 2. So that would be x plus y minus 2z is equal to 12. So the x value we don't know, the y value is 3, the z value is -4. So I'm plugging into equation 2, just writing all the numbers in that. I plugged in 3 for y, because we had found that already. I plugged in -4 for z, because we had found that, and now I'm solving for x. So this is x plus 3. -2 times -4 is 8, is equal to 12. So we have x plus 11 is equal to 12. Pull this over here, it will become -11. So x is equal to 1, giving us our final value. And thus we have a system with 3 distinct values. X is 1, y is 3, and z is -4. Okay, that's number 24, and the answer is C, 1, 3, -4. Okay, getting there. Okay, so I think since we've done enough of these by hand, I'm going to demonstrate a couple of them where the row operations are being done by calculator. But, you know, essentially at that point, the calculator is doing all the work for you. That's why I'm demanding that you do some of these problems by hand. And again, the test will tell you which ones to do by hand. So by calculator, we're going to use the RREF math operation for matrices. So we're going to have to dump all of this into a matrix. So you're going to dump it like this into an augmented matrix, 6, -8, 3, 93. And you don't insert that bar when you're putting it in the calculator, but I'm sure you've seen that plenty if you've been using the calculator for your matrix operations. 18, -24, a 9, and a 2, 7. So you just make a matrix out of it. And then if you have forgotten, you know, the keystrokes, let me just make sure we got the right numbers here. I copied the wrong problem. Let me see if this is the right problem for 25. Hold on for 1 second. Nope, I do have the right one. Check the signs. 6, -8, 3, 93, then it's -30, 40, -15, -4, 65, 18, -24, 9. Okay, so we got it right. So you know that to put this in your calculator, you have to go second matrix, and then go over to the edit function. Whenever you're going to fill up a new matrix with numbers, tell it the size. This is 1, 2, 3 rows. You always have to mention the rows first, and then the columns. 1, 2, 3, 4 columns. So this is a 3x4. So you'll enter everything and then press and then you'll press second quit after you put all the entries in there. Okay, then you're going to go to second matrix again. You're going to go over to math. I'll just write these instructions one time. I'm not going to write it again for 26. You're going to go over to math and then down to reduced row echelon form, because that will take you all the way to the solutions for the system. Okay, that's when you're not showing any of the work. The calculator is doing it all behind the scenes. So here we go. Turn this on. So second matrix, we're going to go over to edit. Tell it the size. This is a 3x4. Press enter to jump into the matrix. Start filling in the entries going across. So 6, enter, -8, enter 3, enter 93, enter -30, enter 40, enter -15, enter -4, 65, enter 18, enter in the third row, -24, enter 9, enter 279, enter. Got them all in there. Press second quit so you don't erase anything. Now go right back into second matrix. Second matrix. This time we're going to do math, and this is the kind of math we're going to do. Down all the way to RREF. And then once you choose RREF, you have to tell it which matrix do you want the calculator to reduce row echelon form. So if you want to name a particular matrix that you want your calculator to work with, then you have to press second matrix again. Second matrix. There will be a list of matrices. Look for the one that you just filled in. We just created this 3x4 matrix in the location A. So just press enter and then put the parentheses, enter again. Okay, so it'll look like this at this point. You choose that one right there and then press enter again. Now see these crazy decimals here? You can get them to change because they're not going to give you run-on decimals in the for answers in the test. So whenever you want to go from decimals to fractions, which are exact answers, hit math, third key down, and then hit enter twice. Enter, enter. And it'll change everything in your solution matrix to the proper answers. If you want to move back and forth so that you can see all the numbers, then you just go like that. Just use the sideways keys. So I want you to notice that the bottom row has all zeros, which means infinite solutions for this particular problem. Last row looked like this. That means infinite solutions. And remember, when you have infinite solutions, you need to express each of the variables in terms of, either the last variable, it depends how many rows of zeros you have. Notice that in this particular problem, last row is all zeros. but so is the second row. The second row and the third row, all zeros. So that means that z can be any real number, y can be any real number, and then you're going to use this top row to get an expression for x. Okay, two strings of zeros here. So you're going to say y can be any real number, z can be any real number, doesn't matter which of those you mention first, and we need an expression for x. So we're going to get this off the calculator and then solve for x. Right, so let me just put that we got this from the calculator. Go up to that top row all the way to the end. Notice that there's a 1 in the x column, so it's 1x minus 4/3 y plus 1/2 z. Let's write that so far. It'll be 1x minus 4/3 y plus 1/2 z. And then let's see what else it says. Plus 31 over 2 is equal to 31 over 2. Because that last number is the constant on the other side of the equation. So we had a 1 in the x column, a negative 4/3, which is the coefficient of y. We had a 1/2 in the z column, which is the coefficient of z, and then the last number is the constant. So if you want to turn this into an expression for x containing only the variables y and z, it can be always in terms of the variables that you said could be any real number, then just solve for x. Isolate the x by bringing everything to the right-hand side. So by the time you bring negative 4/3 y to the other side, it's positive 4/3 y. When you bring the 1/2 z, positive 1/2 z to the other side, it's negative 1/2 z. And then the 31 over 2 was already on the right-hand side, so I'm not moving it. It's remaining right on the same side where it was. So you're going to look for an answer that talks about this, and this expression for x in terms of y and z. Okay, so for 25, let's see, so for 25, that's D. X is 4/3 y minus 1/2 z plus 31 over 2. Y is any real number, z is any real number. Okay, let's do 26. We'll do that one by calculator also. Same comments about how you get it into the calculator with the ultimate operation being reduced row echelon form. Okay, I'm going to go right to the actual matrix. So I can quit out of here. Okay, so we're going to go second matrix. Over to edit. This will also be 3 rows, 4 columns. So you already know the size, so move over, jump down into the matrix, start filling in the numbers. 3, enter, negative 4, enter, 8, enter, 1, enter. Second row, 9, enter, 13, enter, 49, enter, and 0, enter. Okay, last row, negative 3 for x, 3 for y, negative 9 for z, and 1 for the constant. Quit out of there. Then we're going to go second matrix, go over to math operations. Specific math operation we're using is reduced row echelon form. Call up the matrix that you just dumped the numbers into. So that's second matrix. They're in matrix A again because I just typed right over those values that were there a minute ago and close the parentheses. Okay, this time notice that this is the easiest of the cases as far as you doing it by calculator and reporting your answer, because you don't have to worry about coming up with these expressions in terms of other variables. Just whenever you have a string of zeros followed by a non-zero number at the end, that's the same thing as saying 0 plus x plus 0 plus y plus 0 times z is equal to 1, and that is impossible. So we used that operation to do this problem. Last row turned out to be 0, 0, 0, 1. That means that the system is inconsistent. It does not have a solution. Okay, moving on to the last two problems in this batch, and that is 27 and 28. This is 27. It gave you this function and asked you to find A, B, C, and D. So you're going to use matrices to find those coefficients. It also gave you the following four conditions, and you're going to use one at a time. This says when x is 0, the answer is equal to -2. When x is 0, y is -2. This is the y value. So on one side, you'll put this value, and wherever you see an x, you will put the 0. Okay, don't forget, this is x. This stands for y every time I do it. Okay, so it's going to be 0 cubed is 0, 0 times a, 0. 0 squared is 0, 0 times b, 0 again. 0 right here times c would 0 that out, and you would just have d, after plugging in 0 everywhere, is equal to the y value, -2. Okay, moving on to this condition, plugging in a y for x, and this, plugging in a 1 for x, and your y value is this constant over here. Whatever they mention right after the name of the function is always the x value, the number that's by itself on the other side is the y value. Okay, so when you put a 1 in here, 1 cubed is 1. 1 times a, a. When you put a 1 right in here, 1 squared is 1. 1 times b, b. When you put a 1 in here, 1 times c, c. Can't plug in anything for this term because there's no x there. And all of that is equal to the y value. And in this case, that is 5. Okay, and you might want to write what you have right here because you are going to try and create a system. Writing it as an augmented matrix. So you need to line up the columns. So you have to understand that this is the same thing as 0 for the A column, 0 for the B column, 0 for the C column, and for the D, that coefficient is 1. But you had 0 of the A term, 0 of the B term. This is the A column, this is the B column, this is the C column, this is the D column, and then there's the constant that goes with it. Whereas this one would be 1, 1, 1, 1, 5. That's what you would have from this one. 1, 1, 1, 1, 5. Okay, there should be 1, 2, 3, 4, 5 rows. 1, 2, 3, 4, 5 rows. Okay, going on with this problem now. Plugging in -1 for x, setting it equal to its y value. Okay, so if we put -1 right in here and you cube it, -1 cubed is -1. -1 times a is -a. If you put -1 in here, -1 squared is +1. 1 times b, +b. If you put a -1 in here, -1 times c is -c. And you can't plug in anything there, so it's just d is equal to 3. So that would give you a string of values of -1, 1, -1, -1, 1, -1, 1 for the D coefficient, and a 3 for the constant. So each time you create an equation by satisfying these conditions, you are creating a row in your matrix, which you will solve by calculator. Okay, so now we're going to plug in 2 for x, and it'll be equal to this y value. So 2 cubed is 8, 8a. 2 squared is 4, 4b. And then putting a 2 here, 2c. Can't put anything in there because there's no x, and that's equal to 4. That gives you a string of values of 842, 8 4, 2, 1 for this coefficient, and a constant of 4. Okay, so this is the first row of your matrix, second row, third row, fourth row. Okay, this will be row 1, row 2, row 3, row 4. And then we're going to reduce row echelon form to solve for A, B, C, and D, because each one of these numbers represents a unknown that we are looking for. Okay, so why don't we line this up? I'm going to leave it like that. We can just put it in the calculator. Okay, so here we go. So clear. I'm going to go to second matrix. I'm going to dump in that first row, 0, 0, 0, 1, negative 2. So we've got to do that by going to edit. Again, this is 3 rows. I know we have 4 rows this time. So we have 1, 2, 3, 4 rows, and in each row there are 1, 2, 3, 4, 5. So this is a 4 by 5. The size is 4 by 5. And we will end up solving it for A, B, C, and D. We already know the D value. So, I mean, you could put it in as 3 variables, but I'm just going to put it in like this. Okay, so this is a 4 by 5. Whoops, I put the wrong one in. Go back, 5, and then go down into the matrix, and it will have created a 4 by 5 matrix. So let's start typing the numbers. 0, enter 0, enter 0, enter 1, enter negative 2, enter. Then in the second row, it's 1, 1, 1, 1, and then a 5. 1, enter 1, enter 1, enter. 1, enter 5, enter. Okay, now we're in the third row. Negative 1, 1, negative 1, 1. Negative 1, enter 1, enter, negative 1, enter 1, enter 3, enter. Now we're in the last row, 8, 4, 2, 1, 4. So 8, enter 4, enter 2, enter 1, enter 4, enter. Second quit out of there. And we'll go to second matrix, over to math, down to reduced row echelon form. All the numbers were dumped into matrix A all over again. So second matrix, grab that, the name of matrix A, press enter. If you want fractions here, hit math, enter, enter. You don't want run on decimals. Okay, so 1 being that it's in the A column, wherever the 1 is, that's the variable that you've just solved for. The coefficients played the role of the variables this time. So A is equal to, let's make sure that, okay, A is equal to negative 10/3. So I'm going to come now and write this equation. My answer, f of x is equal to, from what the calculator is telling me, A is 10/3, and that is the coefficient of your x cubed term in the original function. Come back here. This 1 that's in the second column, this is your B column. That says B is equal to 6. So it's 6 for B, and that's the coefficient of your squared term. Then we need the C value. The C value was the third column over. So look for the column with the 1 in the C column. That C is equal to 13/3. And that is the coefficient of the x term in this main function. Then it's plus D, and that D value was negative 2. Okay, so we just get the entire function. Oh, you know what? I left off the negative. I was just looking at this. There was a negative in front of that 10/3, and I didn't copy that here. So make sure we have everything in the calculator. This is our final answer. Okay. And let's see what we got here. 27. That would be B. Negative 2/3 x cubed plus 6x squared plus 13 over 3x and a minus 2. That's what we got. 13 over 3. Okay, so that's 27. Okay, last problem is number 28. This is an application problem, and here are the words that go with it. This person comes in, Melody, with $45,000 and wants to invest it in order to receive annual interest. That's what annual income is. The bank pays you interest on the money that you invest in various accounts in their bank. So they pay you to have your money there. So she wants to receive this much in interest. She has this much money to split up amongst the various accounts. There's one account that pays 5% interest. There's one that pays 8% interest, and there's one that pays 12%. And these are simple interest accounts where the way you calculate interest is just the percentage times the amount you're investing. So you have to use these as decimals. This is the same thing as when you're doing any kind of a problem with a percentage. That's 0.05, this one's 0.08, and this one will be 0.12. Okay, you cannot use the percentage value, you need to use the decimal equivalent. So when you're calculating interest, it's just 0.05 times however much you invest in that particular account. For the 8% interest account, it would be 0.08 times however much you put in that account, and so on. Okay, so the best way to do this is to start off setting up categories. In this problem, it goes on to say that Melody wants to have the amount invested in the 12% account to be double than what she invests in the 8% account. Okay, so whatever she's investing in the 8% account, and we don't know what that is, she wants this amount to be double what she invests here. So we don't know how much is being invested here. We know this amount is double that. And we also don't know what this is and have no way of relating it to X. So these are the $3 amounts that are being invested in each of the accounts. You don't have to carry the dollar sign into the equation that we're about to set up. So there are two equations that we can set up here, and we should have two equations because we have two variables. You have to have at least that number of equations if you have two variables. So the amount invested here, well, she walked into the bank with $45,000. Those are the first few words of that problem. So these three amounts that she split up amongst the accounts, the 5% account, the 8%, the 12% account, they total up to $45,000. She just split them up amongst the three accounts. So that's one equation that we can use in our system. Then there's also the interest that she's getting. The interest again is the principal, that's the amount that you invest, times the rate. And that rate has to be a decimal. So if you were going to write an equation that concerns interest, the interest on this account where she had Y dollars invested at 5% would be, here's the rate, just like I mentioned right here, your rate multiplied by your principal. It's just that when we're writing a product, we write the number first, then the variable. That's just the way those are written, products are written. Okay, then if you want to know the amount of interest that she's going to earn on the 8% account, it's the dollar amount. That's what we refer to as the principal, the amount invested times the decimal rate. So plus she's also going to get some interest off this account. All these interest amounts that she's earning are going to combine together, thus the plus signs. So 0.08 times the principal. Then she's also going to earn money off of this 12% account. So it's 12% times the dollar amount invested in that account. The interest that she earns all together is this comment that was made that she wants to have an annual income. Well, when you're investing, your annual income comes from interest. And she wants that to be 4,290. Okay, so you have two equations here. You could clean them up a little bit before putting them into your calculator. So like for instance, this one right here could be consolidated into 3x, 1x plus 2x is 3x, plus y is equal to 45,000. And we can clean up this bottom one a bit also. We could go 0.08x and then this times this. So why don't we combine these two? So this will be 0.0. Oops, that's my y term. I don't want to put that first. Okay, so as far as the x term right here, it's 0.08 plus 0.12 times 2. So let's see what 0.12 times 2 is that, plus the 0.08, just combining those coefficients is 0.32x. And that's the kind of matrix that you would put in your calculator. You could show all the setup, plenty of work that you could show, and then you can dump it into a matrix. This will be my x column, this will be my y column, this will be my constants. Okay, next equation. Second equation would be 3,2 in the x column, 0.05 in the y column, and 4,290 for the constant. Okay, and then just dump it into your calculator and reduced row echelon form. Okay, so clear this out. Second matrix. I'm going to go over to edit to put some new numbers in. This one has 2 rows and 3 columns, so it's a 2 by 3. That's the size of the matrix. Okay, it opened up a new size here. Start typing the numbers, going across. So it's 3, enter 1, enter 45,000, enter. Then the second row is 0.32 in my x column, enter. 0.05 in my y column, enter, and 4,290 in my constant column. Quit out of there. Second quit. Now go to second matrix again, over to math. Type of math that you're going to do. You're going to do matrix math called reduced row, echelon form. Call up the matrix where you just put the numbers by going second matrix. Calling up matrix A where we just keep retyping the numbers because we haven't used 2 matrices at one time in any of these problems that I've done in this video. Press enter, and there you go. The first column stood for x's. So this says x is equal to 12,000. These are the x's. This is the y. These are the y. So the 1 being in the x column means x is equal to 12,000. And in the 1 in the second equation, the 1 being in the y column means 1y is equal to 9,000. Okay, and then you can answer the questions. I think the question here was, how much should she invest at each rate? So she's investing 9,000 here. Be very specific about what number goes with what rate. You can't just give me 3 numbers. I need to know that you know which one goes with which. So we have 9,000 right here for the 5% investment. We have 12,000 invested at the 8% account, and then twice as much in the 12% account. Okay, that completes numbers 12 all the way through 28.